If the list that we are looking at, the list that we are searching through is sorted, which means assuming, let's say that the numbers are already arranged in an ascending order, well, we can do something called a jump search. The idea is to not look at every item one by one like we were doing in linear search. In fact, to look at, every mth item. So for example, we could jump through the list, check, for example, L0, LM, L2M, L3M, and so on. For example, if M were, let's say, 10, then I'm looking at L0, L10, L20, and so on. If we find the target value there, well, we can stop the search. If not, we can then get into a second pass. We do a linear search in a sub-range. Because think about it, the list is ordered in an ascending order. If I find that L, for example, 2M is more than the target, LM, however, is less than the target, I know that the value is potentially in between LM and L2M. So I can go back to LM and do a linear search between this range. So, that way in two passes, we can scan the entire list, and presumably this could be much more efficient than, let's say, linear search, because basically we're jumping. Now, while the concept is, let's say, straightforward to understand, coding this still quite interesting. So what we will do is to look at some intuition first, and then look at several cases, because these cases will become handy as we start writing the code in a clean and neat manner. So, let's start with an intuition here. Basically, let's say we have a book, we have a thick book, and we want to quickly zoom into section 18.4, which is, say, section 4 in chapter 18. Now, a linear search method of this would have been, well, open up the book, go page by page, page by page, page by page, assuming there's no index, let's say, so go page by page till I reach this point. Obviously, that will be quite slow. Well, other method, which is something we often do, in fact, without thinking, is that I can keep opening the book, knowing that 18.5 is quite late. I can just go kind of like, maybe every 30, 35 pages and see where we are. So we can go, for example, section 2.1 to 3.8 to 5.2 until we reach perhaps, let's say, section 19.4. We know we have gone too far inside, and probably we go back a little bit slower to the destination. So, this is how a jump search would look like I said in the very beginning of the videos, that search is something that we do as part of our daily lives. And in fact, these algorithms, if you really think about it, are a formal way of, let's say, representing those actions that we do. But obviously, when we get a computer to do it, our algorithm has to be correct, and hence some care is required. Now, with this intuition in place, I am going to identify 5 cases. And I found that, identifying these cases, drawing them out, thinking through them, in fact, simplified writing of the code significantly. And hence, it's interesting to go through these. The 5 cases that we are identifying are as follows. Number one, the search item is in the list at the jump position. So these are, remember, L0, LM, L2M, and so on and so forth. So this is a lucky case, case number one, where we just happen to find the item very quickly in the first pass itself. So there's no need for second pass in this. The second one is, look, I have the search item in the list, but it is not at the jump positions. Now, this is the case where, look, I am not going to be able to find them in the very first pass. However, when I get to the second pass in the linear search phase, I will be able to find these items. The third case is the search item is in the range. So what I mean is that the search item is built in between, let's say, the minimum and the maximum. Remember, the minimum is in the beginning, maximum is in the end, because the list is sorted, but it is not a part of the list. So this is an interesting case. Basically, we will jump, then we'll do a linear search, and we'll declare that, look, this item is not present. Um, you know, 4 and 5 are actually kind of a little bit trivial in some sense, but anyway, it's interesting to think about them and see how our algorithm takes care of them. Fourth case is really search item is larger than the largest value. So search item is beyond, let's say, the largest value. And clearly we won't find it, although we'll scan the entire list looking for it. Fifth case is search item is smaller than the smallest value. Well, basically this is a case where again, the list won't find it, because at the very first jump we will know that, look, this item is smaller. If you think about it, case number 4 and 5 can be solved rather trivially, but nonetheless, it's good to list them down here so that when we write the algorithm, we can make sure that all these cases are in fact happening. Let's see this a little bit more pictorially. Case number 1 is a situation where, for example, we are going in jumps. So green is what we are searching. The orange item, which is the value of interest, happens to be right on the grid, right on the jump grid, let's say. So I find it, first pass itself, we are done. Case number 2 is where the item is in the list but not on those jump locations. So never mind, we are going to move forward. At some point, we will have an overshoot. we will come back at this point and do a linear search, right? So in this linear search, we'll find this item, because it's part of the sub range. Second pass, we'll find it. Case number three is, look, the item is in this range, but it is not in the list. So again, this can be found easily because I can just go and ask myself, look, I do an overshoot here. So I've gone beyond the items. Overshoot means that my this value is more than the value of interest. So I have overshot. I can just go back here, do a linear search, and I'll know that this item is not present. In fact, we can add a little bit more, let's say, say efficiency to this by saying that, look, the moment I go beyond this value of I search in the linear search, in fact, I can stop. That will add some incremental efficiency to this whole thing, right? Because remember, the list is sorted. Yeah. Case 4 and 5 are rather trivial. Basically, case 4 is when this item is, let's say, beyond the list. So again, when I jump, I go all the way to the end. I in fact then do a linear search in this zone. I find the item is not there. I declare not found. Case 5, the item is smaller than whatever we were looking for, every item in the list. I can just, in the very first attempt, I will know that this is not happening, right? So this is basically not in the list, right? So again, like I said, these two cases can be solved trivially. But now, having understood these 5 cases, quite interesting, think through them. We will come back in the next video and write the code to address each of these 5 and see how each of these is being addressed through our code. Quite interesting to code, so go through it carefully, and we'll do it slowly in a step-by-step manner. I hope you found this interesting. Look at our website www.wipi.in for more such discussions, for more such analysis of algorithms that are interesting, and enjoy programming. Take care. Thank you so much. Bye bye.